This conference will now be recorded.
So usually we have four type of different variables. Okay, you might have seen that already. There are some variables which are declared outside the method, right? Okay, there are some variables that are outside the method. Now, isn't this a variable as well? Int a. What do we call this?
Parameter.
No, these
Input.
input. What
This
do
is
we
a
call
data type. Integer is a data type.
Parameters.
parameters? Yes. Okay, they are called parametric variables. Okay, this is outside the method, so that's why we call it global. Okay, they are called global. These are called parameters. Okay, and this is what we call local. Okay, let's take a deep dive and look into what exactly these three type of variables mean and how do we use them. Okay, now the global variables are actually like a long-term variables. Okay, they live longer than these variables or these variables. Okay, let me show you what I mean. Okay, so first of all, there are four type of variables: instance variables, class variables. These two are outside the method. Okay, they have a global scope. Okay, when what I mean by global, let me tell you that. Okay, now here, if you notice, there is a global variable outside the method. Okay, and then there is a parametric variable. Okay, so when you say scope of this variable, what they really mean is where are these variables visible, how long do they live, and how long you can access them. Okay, now variable a belongs to which method?
Method 1.
Method 1. So if you try to access this variable anywhere outside this method 1, okay, you will get an error. See, you cannot access this variable a from method 2. You cannot. Okay, because the parameter variable a only belongs to method 1, and hence whatever you have here, it can be accessed only inside the same method. Okay, anywhere outside this method, this variable will not be visible. Okay, it's like your own private information that only applies to this one method. Okay, this information is not relevant and not visible to anyone outside method 1. Okay, the same rule applies for method 2. The int b variable belongs to method 2, right? You cannot access them from method 1. Okay, because int b, the variable b, belongs to method 2, so you can access only from method 2, anywhere inside this method. Okay, anywhere inside the method body. Okay, so that's what we call as a scope. Okay, scope meaning where is it visible? Okay, who can see this variable, who cannot? Okay, now when it comes to the global variable x, the reason we call this now when I say this a is only applicable here, can you use the term local? A variable is local to method 1, right? Does that make sense?
Yes.
Right, so it is local. Variable a is local to method 1, meaning it is only accessible, or it is only visible locally inside method 1. Okay, inside method 1. If you try to access variable a here, you cannot. Okay, so you can use the term local to this variable, whereas this one is called global scope. The reason we call it global scope is this variable is declared outside all the methods, right? And hence you can access it from anywhere. Okay, X variable, no errors. No errors. Okay, so first thing first, are you guys clear on what is global and local?
Yes.
Yes, sir.
So global meaning these variables are declared outside method. Okay, these are global scope. Globally as in to this program. It is global to this program. This variable can be accessed from anywhere in this program, in the entire program. So it is global to this class. Okay, whereas parameters are local. They are only visible inside the same method. You cannot see this variable anywhere outside this method. Okay, so these are local versus this is global. Okay, now okay, don't worry about what a class variable is. We have a separate chapter for static. Okay, we have a dedicated chapter for what a static variable is. Okay, now right now whatever you guys did so far, they are called instance variable. Okay, they're called instance variable. This is an instance variable. Okay, whatever the global variable you see here, they are called instance variable. Okay, now instance is another word for object. Okay, instance is another word for object. Now if you recall, when we were constructing objects, what did we do in the memory? If I have to create an object of calculator, okay, if someone creates a calculator object, what happens?
Reference. Creating a new place in the memory.
Correct. We assign some memory location, yes, and then
We assign value.
what do you put in that memory location?
Blueprint.
We put the object in it.
Which,
variables.
yeah, we create a variable with the value, default values, right? In this case, which one will we create?
X0.
The X variable. Okay, this is what we create. If you recall, when we were creating product object, what did we do? Okay, when you say product P equals new product, we allocate memory in a specific address, and inside that box we put a equals 20, right? So that's that global variable. Now the reason we call them instance variable is instance is another word for object. Okay, anytime you create an object, you create some space for this variable as well, don't you? Just like here, when you create an object for product, you created a equals 20 inside that box. Okay, every time you create an object of product, we were also creating this variable inside that box. Okay, so object and instance, these are like synonyms. Okay, they are the same word. Okay, the reason we call them instance variable is every time you create product object, we create a equals 20 in that personal copy. Okay, so look at this example. Every time we did new product, we created a product object, and inside that we kept a equals 20. Okay, so every time you create a product object, we were also creating instance variable inside this object. Okay, so the reason we call them instances because it belongs to the entire object. It belongs to that instance or that object. Okay, Every time you create a product or every time you create an object, you will be creating instance variable. In other words, the global variables in that box. Okay. So in this case, the global variable is
int x
0.
x equals 0.
this is a variable. So this is the one. This is the one that you create every time someone says calculator C equals new calculator. Okay. Now the other thing that you have here, class variable, right? That sounds something like this: static int y equals 0. If you see, there is one keyword here, static. Okay. When you say static, this will not be created when you create a new object. Okay. So let's cover that anyway. All right, so this is your program. Okay, you have a class calculator, and there is one global variable called int x, another global variable called static int y. Okay, so see the difference, static and int. Okay, so now when I create one object, okay, when I create a new object, what happens in the memory?
Allocate an
Assign
address.
object.
Right, so you allocate some location for the calculator object, and
There's x equals 0 and there's y equals 0.
yes. So here inside this allocation, right, inside this memory space, the only one that it creates is the x, not the y,
Not the y?
not the y. Okay, that's the difference. Okay, only thing it creates is x, not the y part. Even though it's a global variable, meaning you write it outside a method, okay, but every time you create an object like this, it will have only the instance variable. So object is also called as instance. Okay, object is equal to instance. Okay, now if I create two such objects or three even, okay, so for C1 we have hashtag 111, right? For C2, what will happen?
New memory location, maybe 222.
Exactly. So we have new memory location for C2, another for C3. Now, if you see, how many objects did we create?
3.
3. You can also phrase the same sentence saying we created 3 instances. This line can be read in two ways. You can say we created 3 calculator object, or you can say we created 3 calculator instances. Okay, object or instance, they both are the same. Okay, you can phrase it any way you want. We created 3 instances or 3 objects, both are fine. Now the reason we call this as instance variable is you created 3 objects of calculator. How many copies of x do we have in the memory?
3.
3.
3.
You have 3 objects or 3 instance, and how many times did we create the x variable?
3 times.
3. And that's why it is called instance variable. Remember, it is tied up to the number of objects that you create of that class. If you create 100 calculator object, in every calculator memory, in every object memory, you will find x, x, and x. That's what instance variable is. Okay. On the other hand, the y will not be created in every copy. Y will not exist inside this object. Okay. And I will tell you in detail when we go to static chapter what happens, where will this y variable can be found. Okay, y variable will not be here, okay, but it will be somewhere else. Okay, and hence instance variable. If you create 3 instances, you will find 3 instance variable in respective objects. Okay, so remember, object is nothing but instance. Do you guys follow?
Yes.
Okay. Now we do not call this. Okay, so imagine if there is a method in the program. Okay, so if there is a method in the program, okay, so now there are 3 variables, right? There is a parameter. Okay, so look at the difference. There are 4 type of variables here. Okay, this is what we call class variables. They are global scope. Global meaning they are outside
The method.
outside the method. Okay, so they are class variables. This is what we call instance variable. Instance means object. It is associated with object. This is what we call parameters. Okay, and this is what we call local variable. Okay, so we have 3 type of variables: class, instance. Parameter is usually found in the parenthesis: int a, int b, string, name. Parameters are found in the parenthesis. This is a local variable. This is found inside the method. Okay, it will be found inside the method. Now class variable, like I said, we'll go in detail when we go to static chapter. Instance variable are usually found outside the method, okay, which you guys have been doing so far. Whatever programs you wrote so far, okay, the variable outside the method, they are all instance variable. And the reason we call them instance variable is they are attached to an object. Okay, if you create 3 objects, you will find 3 instance variable in each of these locations. Okay, parameters and local variable will not be there in here. Okay, so when you create an object, only thing you create in this location is which variable?
Instance variable.
Instance variable, not parameters and not local and definitely not class variables. Okay, only thing you'll find is instance variable. Remember this term, instance variable. Okay, you'll come across that quite often. All right, just a question. I mean, a rough guess. Why are parameters not created here?
Mm,
When you hear the term parameter, what do you recall? What is its role?
It's passing the value.
Passing the value.
No? When you say parameter, what does it indicate? Where does this information reside?
Yeah, passes.
Passes. Okay, when you say passes, who's passing it?
The method is passing this value.
Not the method. Who passes path input? Is it the calculator program or some other program?
No, the calculator program.
So calculator will call its own method.
The person executing it, the sender.
The sender program will pass the input, isn't it?
Mm-hmm.
That information doesn't belong to calculator. Okay. Now, if you are Google software, will Google give you what search? What is that you want to search, or as a user you give the input?
We give the input.
So is it coming from outside the Google software?
Yes, we are giving. The sender is giving.
The sender, the user of Google, is giving the input to the Google software. We are giving the input. Okay.
Okay.
That information is not produced by Google itself. We give the input. So imagine if this is your software, this is the Google software, and the input is coming from outside. Why would Google store that information here? Because they know there is no point in storing int a. Okay. Google, imagine if this is a Google software and it is storing all the information. If there is no point in storing a, because this is a value that is supposed to come from the outside the system, the user, why would it create this variable here then? If it very well knows this information is temporary. This customer today is searching for Facebook. Tomorrow they'll be searching for some hats. Google knows that. Whatever you're giving the input, it's not permanent. What is although what is permanent is the instance variable. Okay, this is the information that belongs to Google software, such as Google's logo. No one is going to input the Google logo, right? It belongs to the Google company, isn't it?
Mm-hmm.
So that's how you need to look at it. Okay, if Google had to write a software, it would look something like this. Okay, if it is a Google software, okay, this is a logo variable, okay, and then you have now what information is owned by Google?
String, logo.
This is the information that Google owns. Okay, does Google instruct you on what you have to search?
No.
No.
No, this is coming from outside the Google software, isn't it?
Mm-hmm.
So there's no point in storing this as an instance variable. Why do you store it here? Because you very well know this information doesn't belong to Google. This information is passed outside this software, outside the Google software, whoever calls your search method. And hence, it doesn't make any sense to create that as a global variable, because we expect user to pass this input to the system. And hence, it is not stored as an instance variable. This, however, information belongs to Google. Google decide what their logo should be, what is the picture image the Google should have. Okay, they decide what they need, and hence they create it outside the method. Okay. All right, so let's look at some tricky things here. Now, all the while when you guys are doing programs, you will come across curly brackets inside the method as well. Okay, so let's look at that first, and then we'll go deeper. Okay, now what would you, okay, let me give an example. You are at an ATM software, ATM machine, okay, and you try to withdraw $1,000. What are the two possible output from that?
You're gonna get the $1,000 or insufficient fund.
Yeah, either you're able to withdraw the money, or it will say you don't have enough fund in your account, right? There are only two options. Either your transaction will succeed or your transaction will fail, isn't it?
Mm-hmm.
Okay.
Yes.
So you tend to write your program code like that. Okay, so something like this: withdraw money if enough balance give money. Okay, if not enough balance, then
Error message.
so show insufficient fund error. Okay, this is your basic logic when you go to an ATM software, to an ATM machine to withdraw money. You enter the withdraw amount, and what the ATM software does is it will check if you have enough balance, it will give you money. If you don't have enough balance, it will show you error message, insufficient fund. Okay. Now, when you write this code, as you know, the Java method, Java program executes how? Yesterday we saw that. How does the Java program execute?
From top to bottom?
Parallelly.
Line by line.
Line by line. In other words, sequence. Okay. In other words, sequence. Now here you have a choice. Now any person who goes to an ATM machine, any one of them could find themselves in option number 1, or any one of them could find themselves in option number 2. So you have to control how and which lines are executed. Okay. Sometimes you want to skip this line for a user who has enough balance, and sometimes you want to skip this line when you don't have enough balance. Okay. So what we do here is we put a curly bracket like this. Okay. We put a curly bracket to indicate that all this bunch of code should only be executed if the customer doesn't have enough balance. Okay. So you give the money and you show the latest balance. Okay. These are the lines of code that you want to execute, and these are the lines of the code you don't want to execute. Okay. If you find enough balance. So these curly brackets are not just meant for classes, is what I'm saying. Okay. So far you guys are aware about curly brackets at the class level and at the method level. These are the only two places you found them, don't you? So here we can actually write bunch of code. Okay, and we can decide these lines of code will be executed only if this condition satisfies. Okay, if customer has enough money, we will execute these 3 lines. If customer doesn't have enough money, we will execute this line instead of the below 3. Okay, you can do that by using curly brackets. Okay, so this is the line of code that comes as a block. Okay, we call them as blocks. Okay, so what you do is you write the program in such a way that it is capable of handling multiple scenarios. Okay, you don't write one program for one scenario. You have one operation, withdraw. Okay, and it has 2 outcomes, a successful transaction, a failure transaction. So what we do is we write all the code for successful transaction and group them in one block, and we write all the lines of code for failure transaction and group them in another block. Okay, so this way you can decide what are the set of sequences you want to apply. Okay, so basically what is curly bracket? It will group a set of lines in one block. Okay, it will group bunch of lines in one block. Okay, so let me show you a simple example. Okay, so this is the method, public void method a, int a. Now if I call this method and pass the value 25, what will happen? This symbol
It's gonna say greater. It's gonna say greater.
Correct. So not all of you are aware about these signs, so I'll tell you what this is. This sign tells you if the left hand side is greater than right hand side. Okay, so this symbol indicates if the left hand side is greater than right hand side. So if I pass a as 25, is 25 greater than 20?
Yes.
Yes. So now if this is true, if this condition satisfies, only these two lines are executed. Okay, it will basically print greater, I'm in first block, and it will skip all these lines. Okay, so when you're writing programs, it allows you to control what needs to be done. Okay, now here, any customer who is calling method 1, they could pass any number, right? 1 to a billion. They could pass a 0, 10, 20, or a billion. So you never know what kind of number will be passed to this method. Okay, so what we do is we take care of both these conditions. What if the customer passes a number greater than 20? What should I do? So we group all those lines in something called block. If the number that customer pass is less than 20, what should I do? All the lines for that condition will be grouped in another block. Okay, so that's what the blocks are. Okay, block will basically allow you to segregate a bunch of lines in one group. Okay, so you can decide, do you want to execute all of them or nothing? So in this case, either everything, all the lines in this block will be executed, or all the lines in this block will be executed. It's a either or condition. Okay, either this will be executed or this will be executed. Okay, so that's what you can use the blocks for. Again, we'll go in detail when we go to control flows and all. Okay, all right, first of all, you know the scope of X. Can I print X variable here?
Yes.
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 No error. How about here?
Yes.
Yes.
Here?
Yes.
Yes.
Anywhere, basically, right? The global variable.
Mhm.
This is a global variable. You can access it anywhere. So that's this example. I can access that variable anywhere. It is visible anywhere. Let's go to the A variable. Can I access A variable here?
Yes.
Yes, because A variable
Local.
belongs to method 1. So you can access this variable anywhere inside the same method.
Mhm.
Okay, so if you want to see where this method begins and ends, just double click on this bracket. Okay, so this is the coverage. This is the coverage for variable A. You can write variable A anywhere in this highlighted section. Okay, and you still can access it. Okay, but outside that section, outside the method coverage, it is not visible. Okay, you'll get error. Okay, so now you know the scope of instance variable and you know the scope of parametric variable. Let's see what is the scope of local variables. Okay, now before we jump into that, think about local variables as something as a temporary data that you store for just for a while. Okay, now imagine you walk into a grocery store, okay, and you are on a tight budget, okay, and you're just doing the math in your mind. Okay, you let's say you just have $10 and you can only buy few things, not all of them, right? So you walk into the grocery store and you see fruits, bananas, mangoes, and all that, and you calculate in your mind, okay, if I buy one mango, which is $5, and one banana, which is $4, it will be 9. Okay, that's my budget. Okay, that's what you calculate. Now that information, right, on that particular day, that information that you had, banana was 5, mango was 4, put it both together, you have $9. Now, will you remember that information until the day you die?
No.
No.
You don't, isn't it? That particular information was only relevant on that particular day when you were on a tight budget of $10. So that's a local variable. Okay, you only need that variable for that one shopping when you were on $10 budget, but you don't store that information until you die, right? That's local variable. Okay, you follow?
Yes.
Now, will you remember your name and your date of birth till the day you die?
Yes.
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 That's a long-term variable. Until that's a long-term information that will be part of you, and you will remember that until you don't exist. That's instance variable. Okay, this information will live and die until this calculator object exists. When the calculator object dies, this information dies along with that. So think about the long-term information, your name and date of birth, as this variable. Whereas this local variable P and Q, it is just a short-term information. It will not be available to you forever, and you don't even care about that. Okay, you don't care about this information because it's just for the moment. Okay, the moment you're done with your job, that is shopping under the $10 budget, you're done. The next month you have a budget of $1,000 and you go to grocery store and you go crazy. You will never remember what happened the last week because that was not relevant back then. That was just a temporary information based on your budget. That's how you need to relate the local variable and the instance variable. Do you guys follow?
Yes.
Okay, this is a short term and this is a long term information. This variable lives and dies along with the calculator object. Okay, now the moment this object dies, everything associated with that will die. It's gone. What happens to this?
Gone.
That's also gone. But it will live as long as the calculator object C3 lives. Okay, as long as the C3 variable lives, this will also live. Okay, but when this dies, this will go away as well. Okay, so this is the just like your example. As long as we exist, we will know what our name is, we will know what our date of birth is. That's the instance information, instance variable information. Okay, on the other hand, these variables that you see inside the method, these are local. This is short-lived. We don't care much about what number we had in mind like 2 years ago. I don't even care what number I was thinking or what program I was watching, okay, or what movie I was watching 2 years ago. That information was only relevant on that day, and I totally forgot all about it. I don't remember anything what I did like a week ago. All that information is not permanent. That was only relevant for that day and that day alone. The same applies to local variables. Okay. Now, local variables are typically bound to a block. Okay. Now this is a method block. Okay, this is a method body or method block. So there is a curly bracket within that block, right? So this would be like a child block, isn't it? A sub block or a child block. How about this block? Okay, so let's tag them.
Grandchild.
This is block 1. This is block 2. And this is
Okay.
block 3. Okay, now block 3 is inside
Block 2.
Block 2 and block 1.
Block 1.
and block 2 is inside.
Block 1.
Block 1.
Okay, so you guys follow the block part, right?
Mm-hmm.
The variable P belongs to which block?
Both.
Block.
Block 2 and 3.
Block 1.
Oh, sorry, yeah.
Isn't it
It belongs to,
outside the block 2?
yeah, sorry, yeah.
If it is outside block 2, then it is inside what?
Block 1.
Block 1.
I mean,
Block 1. Where does the Q variable belong to?
block 2.
Block 2.
2. Yeah.
Where does the R variable belong to?
Block
3.
3.
Block 3. Okay. So typically what happens to local variable is they die after their block cease to exist. Now this is where the block 3 ends, right? If you try to access the R variable, you'll get an error. Okay, because R variable is part of
Block 3.
Only.
block 3. So the moment this block ends, this variable is also gone. Now what will happen if I do print
B.
Q? Can I print Q here?
No. Yes.
It's
Which
inside
block? Q belongs to which block?
block 2.
Block 2.
Block.
Oh, yeah, you can because that's a.
Is this line still inside block 2?
Yes.
Yes.
Part of block 2.
Yes. You're still inside the block 2. So of course you can access them. How about P variable?
Yes.
Yes.
Yes. P belongs to block 1. Double click here. What is the coverage? All the way till the okay, and hence P can be accessed anywhere. Okay, so if P variable belongs to block 1, double click here, and all the places that you see this highlighted, everywhere you can access P variable. P, 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 anywhere. When it comes to Q, Q belongs to block 2. The coverage ends here. Until the last line of the coverage, you can access Q variable, but you cannot access outside the block 2. Okay, just like what example I gave you, information. What you were thinking at exactly 7 a.m. today morning. Does anyone remember? What
No.
information you had in your mind? Thinking about something. Okay, either you were singing, you were cooking, or you were talking to someone. Okay, or you were doing some activity. Does anyone remember exactly what we did at 7 a.m.? No.
No.
As soon as we were done with that part, we forgot. The same applies here. Okay, as soon as that block ends, that information is not valid. Nobody cares. It was just temporary. For some reason, we created that, and you'll be done with that. Okay, that's what local variables are. Local variables belongs to a block. Okay. Now one more question. Can I write Q here?
No.
We cannot. Even though that line is in block 2, we cannot. Why?
Because we define
The sequence.
below and sequence.
Okay. This variable did not exist until line number 10, isn't it? We declared or we created this variable on line number 10. So how can you use something which has not been created yet? Okay, Q variable exists from line number 10. If this variable exists from line number 10, you can't access it. It has to exist. Only then you can access them. Okay, even though this line belongs to block 2, doesn't mean you can write it anywhere. You can only use the variable Q from the line where it exists till the end of the block. Okay, from the line it exists till the end of the block, not anywhere, not before the variable exists or not after the block ends. So do you guys follow how the local variable, what exactly the need for local variable is and how they are visible in all the blocks?
Yes.
Okay. All right, so how would we use programmatically? Okay, think about this. Let's say you have a very complex mathematical formula that you're writing the software for. Okay, so you have a formula, something like this: a times b times a times plus a. Okay, this is your complex formula. Okay, this is your formula, what for some kind of a problem, length and breadth, whatever you call it. Okay, now when you're calculating this in your mind, how do you calculate? How do you calculate that in your mind?
Blocks.
First division, multiplication.
So you go simply like this, right? First you take care of the first two multiplications number. You say 10 times 5, 50. What do you do with that 50 number?
Save it.
By 20.
It's temporary, right? It is only meant for the next calculations. So then you say 50 divided by 10. So wasn't that number 50 required for you to calculate the entire formula? You needed them, but was it permanent?
No.
Okay, if this is too complex, let me give you something like this. Okay, if I give an example like this, I will ask you, can you give me the answer for this formula? If I ask you, the way you do that in your mind is you take the first two part and you say 10 divided by 5, 2. Then 2 plus 5, 7. Then 7 minus 10, minus 3. Minus 3 plus 10, 7. Isn't this how you calculate?
Mm-hmm.
Now here is the question. What do you remember? The last number, or do you keep this all intermediate numbers in your mind?
The last number.
Last
The
number.
last number. So isn't this a local information? It was needed just for a while and then you don't need it anymore?
Yes.
But you needed them. Even though it was not useful in the long term, you needed that for the short term, isn't it?
Mm-hmm.
That's how you use local variables as well. Okay, someone asks you to write a software for this formula, and what you do is you create 3 variables which were required for you on a temporary basis. Okay, when you are done with that, it's a local variable after all. You will forget them, and so does the program. This information will be forgotten. This is the only one that will be used in the long term. This will be your local variables. Okay, now let's get more technical. The loan simple interest program was something like this, right? What is the input?
And time, right?
Interest.
Okay, principal, time, and rate. So what we typically do is we store all the information, let's say temporarily. So how do you multiply the formula for simple interest?
T time or divided by 100.
Okay, the first part. What will be int b equals to?
A times.
A times
Right.
B.
And what will be the last part?
B.
B by 100.
See? And finally, what will you return?
C.
So weren't these temporary variables that you created just for a while to remember what the first part of the multiplication was?
Mm-hmm.
That's how you use the local variables. Local variable is used to hold information for a short while. In the end, of course, all I need is a final number. Principal times time times rate divided by 100. But what we do is we do one by one. We calculate principal and time, keep it in a variable, okay? And then we take that variable and multiply with rate. So indirectly, isn't B equals to principal times time times rate?
Mm-hmm.
Okay, if you just replace A, wouldn't this be something like this?
Mm-hmm.
That's what we did. Okay, but it was just temporary placeholder for storing information. Just like what we did here. If I ask you to calculate this formula, you will go one by one. You will divide 10 by 5. You will keep the result in your mind for a while. 2. That's what we did here. Okay, that's how you will be required to use local variables. You just need them for a short while before you process on the next step and the next until you get finally what you want. Okay, that's local variable. Does everyone understand how and when you would need this?
Yes.
Yes.
All right, so now that you know what is the scope, how you can access them, what is the visibility, what is the relation between instance variable that is global and local, how do you relate them to the real world? Okay, now let's see what will happen when there is a conflict. Okay, now P variable is accessible from, tell me the line numbers, from which line to which line?
7 to 17.
Yes, from the time you declare this variable, from there till the block 1 ends, right? You can access P variable anywhere. What happens if I declare P here?
Then from line 10.
That's a conflict.
Mhm.
Okay, that's the conflict. What does it say?
P.
Duplicate local variable.
Yeah.
Because P already exists on line 7 and it will be existing till line 14. P variable will exist till line 14. So in this coverage, if you declare another local variable, you'll get the error. Now the variable A is visible on which lines?
On 6 through 15.
Can I access A variable here in this method?
No.
No.
In add? Not in
No.
add?
No.
Anywhere outside this method?
No.
No.
You can't. So if this variable A is only visible inside this method, what happens if I declare one more variable A here?
Duplicate.
Same, duplicate. Okay, because A is visible throughout this method. Okay, so duplicate local variables are not allowed. If you find duplicate variables, basically you have declared it somewhere above in your method. Okay, if you have a variable D, anywhere you declare that D variable, you'll get an error in that coverage. Okay, how about I declare the p variable here. On line 14, how about I declare the p as in Paris?
Oh, it's error.
So what is the coverage of p variable?
To line 14.
Till line 13, isn't it? Okay, if you're confused on the block, just look at the alignment. Okay, this opening bracket block 2, isn't it aligned with this bracket?
Mm-hmm.
Oh, okay. Yeah.
This is aligned with this bracket, isn't it?
Mm-hmm.
Oh,
So where does the p variable end?
13.
13.
On 13. Okay, the block 2 is aligned here. So hence, no problem here.
Mm-hmm.
Okay, because p variable would not exist after that line 13. So now you don't have duplicate. Okay, it is outside that block where it ends. How about I declare r variable here?
Yes, it's fine.
Yeah, we can.
Perfectly fine. Int
Mm.
r dies on this line. Okay, but if there is a coverage, and in the same coverage, if you try to declare one more, that's when you run into trouble. What if I declare p variable here?
We cannot because within block 2.
Right, we cannot, because p variable on line number 9 has a coverage in block 2. So all the way from here till block 2 ends, you cannot. So if you declare p here, now you get the error. Okay, do you follow how the local variable, duplicate variable usually comes up?
Mm-hmm. So if you declare int x, that's a duplicate too, right?
Yeah, we'll get to that. We'll
Oh,
get to that.
okay.
That's a next important topic.
Okay.
The duplicate variable only applies to methods and local variables. If you declare x, no problem.
Oh, no problem.
Okay, so now the question is, if I print x, will it print 10 or will
Yeah,
it print 0?
it will print
It will
10.
print
It
10. It's
do
inside
the,
the same method.
yeah, we're gonna do the.
So think about this like this. Now you have two friends called John. One John, the first friend, John, is sitting right next to you, and another friend, John, is in another city. If you call out the name John, who will answer?
Right next to me.
Right next to you, the local, the closer one, isn't it?
Mm-hmm. So it's gonna print x or 10.
What will it print? 10 or 0?
10.
That's it. Okay, so if there is a conflict between the global instance variable and the local wins. Just like how it is in your personal context. Whoever is closer to you with the same name, they will answer you.
Mm.
Okay, so duplicate variable only applies to method parameters and local variables. Okay, they don't apply to global
For
and local.
instance.
They don't apply, but you need to remember, if you call out the name X, who will answer? Okay, it will be the local one. So it will print 10. Okay, it won't print 0.
Mm-hmm.
All right.
Yes.
This conference will now be recorded.
A statement consists of variables, method invocation, and assignment. Okay, so outside these lines, what do you see? Okay, in this program, outside these lines, public void, what do you see, right? Public everywhere.
Mm-hmm.
Outside these, whatever you see, they're all called statements. This is a statement. This is a statement. This is a statement. So does this, this. Anywhere you see this public class, public void method, okay? Anywhere that you see method declaration or class declaration, okay? Anything outside these lines, they are all statements. Okay, so if this is like a skeleton, not skeleton, but an empty shell of the program. Okay, when you write a program, you start like this. Okay, this is the empty shell of Facebook, isn't it?
Yes.
Does it have anything here? Profile, Facebook logo, Facebook profile name or username, anything you see here?
No.
Does this login method do anything?
No.
Isn't it empty?
Yes.
So statements are the ones which bring that life in your program. Okay, once you start writing the code, okay, owner, logo, these are all statements. Here you write the code to compare user ID password, show welcome message, show error message. These are all that makes your program actually work, and this is what we call statements. Okay, this is what we call statement. Now statement can be variety of categories. Okay, it can be variable declaration, right? It can be variable declaration. And what is this?
Initialize.
Initialization. Okay, you are initializing the variable d with a value 10. What's the difference in this line and this line? Would you call this line as initialization?
No.
No. Why not? What does the term initial mean?
The data type is not initialized.
The first time. The first time that you had the value assigned, that's what we call initialization, isn't it?
Initial first.
Initial, the first time. So the first time when you created d variable, what was the value?
And
10. So this is what we call initialization. This is a new value we are assigning the second time, isn't it? So if this is initialization, this would be assignment. Assignment is typically when you assign some value the second time. Okay, so you understand the difference between this three, this, and this?
Yes.
Okay, so think like this: int x, x equals 10, x equals 20. Now what are these? Which one is, like I told you, the three kinds? What is line 1?
Yes.
Okay.
Is it declaration, initialization, or assignment?
Declaration.
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 First
What is this?
declaration. Initialization.
Initialization. And what is this?
Assign.
Assign. There you go. You declare that there is a variable x of type int. It can store numbers. You declare, you announce. This is where we announce, this is where we give the value first time, initialization, initially, first time. And this is assigning value later or reassigning, whatever you call it. Okay, so this statement we call as assignment. Okay, assignment, initialization, declaration. Okay, all these are statements. This is a statement for declaration, initialization, assignment. Most of the time we don't split them in two lines, right? We just do it in one. We just do it in one. So this line is more accurately, it is declaration and initialization, isn't it? We declared and we initialized. It is both actually. Do you guys follow?
Yes.
Okay, we just skipped the one part. Instead of splitting that in two lines, we just took care of on the same line where you declare, we initialize as well. In the same line we did that. Okay, so that's what declaration, initialization, assignment is. Now what other lines do you see in this code? Other than anywhere you see public void method or public class, other than these lines, what else do you see?
System
You know what this
dot
line
out.
is, right?
Mm-hmm.
This is initialization statement. This is
Declaration statement.
declaration statement. Very good. This is
Initialize.
Statement.
initialization.
Initializing.
This
Assignment.
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 Statement.
What is this?
Bracket. No?
Statement.
Comments. Block.
It's a block. Initialization, initialization, initialization. What is this line?
Statement.
Look carefully and tell me, what is this line?
Method.
You have done a similar thing.
Method.
Yes, it's a method.
Oh, it's a method.
Which method are we calling?
Output.
Prints.
Method.
Println.
Println is the method we are calling actually. This, in fact, is a method call. Okay, this in fact is a method call. Don't you do that thing when you're calling another method? What do? We use the dot operator, we call the method name, and we pass a parameter, don't we?
Yes.
Yes.
So this is a method that is accepting string, isn't it?
Yes.
So that's your another kind of statement. This is a method call statement. You can say method call or invocation statement. Method call or invocation statement. So your program is made of all those things. You either have variables, declaration or initialization, or you have method invocation, you have assignments, or you have blocks. All these lines put together, your program is basically what built off. Okay, that's all your program has usually. Okay. All right, so what's the main thing I told you about the equal sign?
Assigning.
Assigning the value.
Assigning the value from where to where?
Right to
Right
left.
side to left.
Right to
Right
left.
side to left. Okay, so if I do like this, what happens? When I print A, B, C, just a minute. When I print A, B, C, what will happen?
AB. 10, 20, 10.
10, 20,
10.
And right hand side values goes to the left hand. Okay.
Left.
Yes.
If I print like this, will it print 2020 or 1010?
2020.
Again, equal means right hand side to left hand side.
Right.
What do we have on the right hand side?
Oh, 10.
So you put that 10 value on which variable?
Both.
The B.
Left.
What's the new value of B?
10.
10.
Okay, whatever you have on the right hand side will be given to the left hand side. Remember that. Variable A, whose value is 10, that 10 now gets copied onto
B.
Left hand side.
From
B.
left hand side.
okay, right hand side to left hand side. We call this as assignment operator. Now, while we are here, let's do this thing. Product P1 equals new product. Okay. Then we have another P2 equals new product. Now, when I do this, okay, let's go here in the memory snapshot and see. Okay, just for your understanding, I will copy the product class there. Okay, this is your product class. It has int a equals 20. So what happens in the memory? As usual,
What
what do we have inside?
A equal 20.
This address goes where?
P1.
The same happens to P2. New product, right? Right, so we'll create one more object for P2 with a different address. Now here is what I want to see if you guys understand. P1 equals A, I'll set to 30. What will happen?
The P1111 memory address is changed to 30. A.
Correct. P2 dot A to 40.
20 into 40.
Reference 222 will change to 40.
Okay. Now what I will do is P1 equals P2. What happens now?
It will
No,
take
40 is
40
turned to 30.
because P1 will print 40.
No, in the memory.
No. P2 is gonna be change the value of P1, which is 30, is gonna be 40.
Forget about 30, 40. What is the value of P2?
It's gonna
40.
change. It's gonna change the address of P1 to 222.
Yes.
Yeah.
Vardha, do you understand what the value of P2 is? P2's value is not 40, not 30, not product. No, the reference variable. So reference variables values are what?
The memory located.
The memory location. Oh, yeah.
So P1 equals P2. What change? What will happen in the memory?
Now the P1 is 222.
Yeah,
Yes.
P1 will get the same reference to 2.
This is what will happen. Guys, pay attention. I'm telling this often. Reference variable do not point to the content. What does it point to?
Memory location.
The location.
The address, the memory location.
Oh, the A
P1,
is
P2
the,
is
oh,
the reference variable.
okay.
Don't point to A or B or age, item name, no. They point
Okay.
to the address where the product object exists.
Mm-hmm.
So now when I print p1.a, what will it print?
40.
40.
Okay, I'm good.
p2.a,
40.
40.
they both are pointing to this address. It will print 40, both of them. Now what will happen if I do p1 equals p2.a?
Oh, here it's changing. Oh,
What is p1?
P2.
Memory address.
222.
Okay, what data type is p1?
Integer.
p1.
Product.
It's a reference.
It's a reference variable of type.
Integer.
Constant.
Product.
Okay, this is where you guys understand the terms. Okay, the whole exercise we did 3 days ago. When I say data type, I'm not talking about the memory. What am I talking about? You understand what a data type is? You look at the declaration and you see what class I wrote behind the variable name. That's the data type. When I say value, am I referring to product?
No.
No.
That's when I'm referring to this address or this number. Okay, so you have to keep track of these terms, the whole practice that we did. What is the data type of A?
Int.
Integer.
Very good. What is the value of A?
20.
20.
20.
That's how you need to remember. What is the data type of P1?
Product.
Product.
What is the value of P1?
Null.
Not null, we gave new product.
Some
It is
memory.
some reference address.
Reference.
Okay, remember, data type means I'm asking what is the class before that variable, or what is a primitive data type before that variable. Okay, this is what data type is. These are values. Hashtag meaning reference. It's an address. Reference address. Hashtag. These are literal values. 30, 40, John. Okay, remember the difference. Data type and values. So when I'm explaining, I will always use these terms. Initialization, declaration, assignment, data type. If I say data type and you guys are looking here, then it's totally wrong. You wouldn't understand anything. Okay, all right. So coming to this, what is the data type of P1?
Product.
Now, carefully look. What is the data type of P2 dot A?
Integer.
Yeah. Int.
Integer. Yes. P2 dot A. P2 is what? It's a product. Inside product, if you look for A, you can find its data type as well, don't you?
Yes.
So left hand side we have P1, which is product, and right hand side what we have?
Integer.
Integer.
Integer. So does that sound good? Does that sound correct?
No.
No.
This will be an error. Okay, so when you do assignment, the main thing you need to remember is both the side have equal values. If I do like this, Does this sound right?
No.
No.
No. Can you assign a number to a string?
No. No.
You can't. Both the values should be same. If left hand side you have one data type, B, string, right hand side should be the same data type, string. If A is string, then it is okay. But this is not. This will give you an error. How about this? Will this give an error?
No.
No.
P1.a, P2.a, aren't they both integers?
Yes.
You're good there. No problem in this one. Okay. What will this print?
$40.
40.
No, the first line number 7, what will it print?
30.
30.
Line number 8,
40.
40.
line number 10,
40.
40.
line number 11.
40.
Yes. So basically what you did in here, it is very clear why 30 and 40, because P1.a was 30, P2.a was 30. So we were good there, no problem. On this line, what we did was, on the right hand side, P2.a, take the value, remember, take the value of P2.a, which is
40.
40.
go to P2, go to A, and get the value 40. Take the value and assign it to the left hand side. Left hand side we have P1.a. So take the value 40 and assign to P1.a. This will be 40 now. Okay, and hence when you say P1.a, P2.a, it will still say 40 and 40, even though they are two different objects pointing to different location. They are 40 and 40. Okay, so remember, assignment operator, you should only have similar kind. Okay, you cannot do this. Okay, you can't do this. V is integer and W is
Numeric.
what's the
Alphabetic
data type
numeric.
of W?
String.
String. Data type of W is string. That's not allowed. Can I do X?
Yes.
This is fine. V is integer, X is also integer. How about A?
Yes.
Yeah.
Both are integers. How about Y?
Yes, it's
Yes.
also
Still okay. Even that's an integer. Okay, left hand side, right hand side, it should be same. If they are not, you get an error. Okay, so remember, this is very scary. So you have to be extra careful. If you really mean swapping the address to the same location, if you really want to do this, then it's fine. Okay, but be very careful when you do this thing. This could entirely mean something else. Okay, imagine if there are two bank accounts, two customers. One has $1 billion, another has like $10. You created two objects for both of them. What happens if you swap references like this?
There will be issue in the balance.
Both of them will either see billion or both of them will see $10, isn't it?
Yes.
Be careful when you use this kind of assignment, unless you truly want to merge them. This is basically merging P1 and P2 to one location, to one object. And this makes sense when you actually are, trying to do something on purpose. Okay, imagine if you want to open a joint bank account. How do you do that?
Then you can merge it. Then it's gonna save.
Okay, you can merge them. If you want to create, if your software wants you, if you're working on a section which deals with joint account, you'd rather do it like this. Okay, bank account, partner one, new bank account. Okay. Now, since it is a joint account, if you do like this, what will happen? Do they have two objects or just one?
Two objects.
Two objects.
Two objects.
They have two objects. So is it truly a joint account?
No.
No.
So how do you fix that? How do you create a joint account software in this line?
Merge it.
Partner 1 equals to partner 2.
Exactly. This is what you do. You create one object and the partner one reference variable will be assigned to partner two. So both of them, okay, when you did this, let's say the bank account object was created in location 111. So what is the value of partner two?
111.
111. So aren't they both pointing to the same object in the memory?
Mm-hmm.
Yes.
So when one partner does deposit or withdraw, will that be reflected to the other partner as well?
Yes.
Yes.
That's the trick you use. So sometimes you on purpose tend to do this. Okay. But if you really did not mean to merge them, this could be very dangerous. You are on a shopping website, you bought one sock and you got a bill for $100,000 because other person whose cart was merged with you bought a Ferrari. It could be very risky merging objects unless you truly want to do that. Okay, so be careful when you're doing reference variable assignment. Okay, when you assign reference variable P2 to P1, that could lead to many problems. Okay. All right, so the arithmetic operators, you already have seen these, right? These are usually used with integers or floats. Okay, you don't use it for any other thing like character or boolean. Okay, you can use the arithmetic operator for anything number related, byte, short, int, float, like that. Okay, those are all numbers. Okay, so this plus will basically add the first part and the second part. Minus will deduct the second part from the first part. Multiplied, of course, it will create the product. Division, it will divide the number. Reminder, what's the difference in divide and reminder?
Percentage or
So the extra.
9 divided by 2, what do you get? Sorry, 9 divided by 4.
1.
1.
1. 2 dot something.
The value is 2 and the remainder is 1, isn't it? 4 2s are 8. The remainder is the number which you couldn't divide anymore.
Yes.
Okay, if you do 9 divided by 4, the actual value you get is 2. 4 2s are 8. But you still have one number remaining, right? To make up to 9.
Yes.
So divide gives you this, whereas modulus gives you 1. Okay. So when you say 9 divided by 4, you get 2. And when you say 9 modulus, it gives you the remainder. Where is the percentile? Okay, this is for reminders, whatever remaining number, and this is for the whole number. What happens now? What do you get here?
3.
3. What do you get here?
0.
0. Okay, when you divide 4 by 12, nothing remains. It's a perfect division. Nothing remains. 4 divided by 12 divided by 4, you get 3 times. Remainder is nothing. Okay, so that's what the modulus operator is. All right, so these are relational operators. Okay, so basically you can use them to check compare two numbers or floating numbers. Okay, if you want to compare two numbers or floating number, you can do that. Let's take a live example and you can see that this is used in a lot of places. Take the withdraw. Okay, you have a bank account class. Here now in this program you have to deal with two variables. Okay, let's see what you have learned. Withdraw amount and balance. Tell me, where do you write the withdraw amount variable and balance variable?
Withdraw amount in the parameter, balance in the like global variable instance.
Very good. Does other people understand why? Why does balance go here and withdraw go here? Anyone?
Because withdraw amount is where sender is passing the value.
Yes. Now when you go to ATM machine and you want to perform the withdraw operation, do you just enter the withdraw amount or you enter the balance as well?
Just the
The withdraw
Just the withdraw amount.
Just the withdraw amount. So it makes sense to have withdraw amount as the parameter, but balance doesn't make sense because no one remembers. We have like some odd balance. Our balance is usually like 123.9989. Who remembers the balance? No one. So do you ask customer to enter their current balance and amount? No. You just ask them to enter what is the withdraw amount. Parameters means input. So if you look at the ATM software, it only asks you to enter the withdraw amount. That's why withdraw amount goes there and balance goes up there. Remember, these are no different from your everyday activities. It's as plain and simple. You have to just put your thought process and try to relate them. All right, so here, if you want to compare, forget about the logic and everything, you have these information scattered, withdraw amount, balance. What is the condition you apply here to let the customer withdraw money?
Balance.
You compare balance and withdraw amount. That is, of course, a given. So what comparison do you need to do?
If amount is bigger than
$200, then
is less than
Withdraw.
$200,
Or less than that.
it's $200.
or
If
less
amount
than
is less than 200,
Okay, not the value. You have to always deal with variables. Okay, never, when you're discussing logic, this is just an example I'm giving you. But do you feel that every customer will have a balance of 200?
No.
No.
If
So
amount is less
always,
than
when
balance.
you're writing logic, always talk in terms of variables or methods. Do not consider the values. So how do you phrase this?
If
If
amount is less than balance.
right, if withdraw amount is less than balance, then you allow them to withdraw, isn't it?
Mm-hmm.
That's what we call relational operator, because you're comparing relation. You're checking the relation between variable 1 to variable 2. That's a relational operator. So ideally here, you do something like this. If balance, this is what we call greater symbol. Look at the opening. This is greater and this is on the lower side. Higher side, lower side. So what we are checking is if balance is greater than withdraw amount, then give cash. Okay, then give cash. The other way around, you can do that as well. If I do like this, what does that mean?
The same thing.
The same thing, I just reversed it. I reversed the symbol and I wrote variable on this side and this side. So again, the same symbol. Withdraw amount is less than, okay, look at the smaller side. It is less than balance. Balance is greater than withdraw amount. This is what we call relational operator. You use them every single day. You compare two numbers. You go to grocery shopping and you have a budget variable, and what's the other one?
Equal.
Your total cart order amount, whatever you call it. So you have budget variable. If your budget is this much, if the budget is greater than my final shopping total order amount, you're comparing two numbers, aren't you?
Mm.
Yeah.
So what other examples can you think of when you want to compare two numbers?
Equals to.
Just forget about this. I'm just saying generally in your everyday life, are you comparing any two numbers for any reason? Okay, you're going to your friend's house for the first time and they gave you the house number 3250. You're comparing, there are several buildings, you're comparing, is this building 3250? Is this? When you see that you have a 3250 building, you enter. You're comparing numbers everywhere. You're comparing phone numbers. You want to send amount to your friend. What do you compare? Their bank account number, don't you?
Mm-hmm.
So whatever bank account number you're entering, if it is the same as your friend's, you transfer. You're comparing number all the times.
This conference will now be recorded.
Right, so you have a greater than and less than comparison. What other type of comparisons do you do?
Equals to.
Equal to,
Equals
not
to,
equal to.
not equals to. Take the banking example and tell me equals to, not equals to usage. Okay, this is a usage of less than greater than for the withdraw function. In the ATM example, do you have any usage of equal or not equal?
Yes, pin.
PIN. So this is the PIN that you have on your account. Okay, that's a bad PIN. So what do you do here? What do you compare?
If 4-digit
equals
PIN
to
equal the customer entered.
digit.
Here, there is a slight difference. You need to write two equals for comparing equals to.
Oh yes,
One equals means one equal sign means what?
assignment.
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 This is
Sign.
assignment. The right hand side value goes to the left hand side variable. This is assignment. Two equal sign means
Comparing those two.
comparing. Yes. So basically what we do is when you create a bank account, you decide what the 4-digit PIN is going to be. And every time customer is trying to access your ATM, it could be you or someone who stole your card, your debit card. When they go to the ATM machine and they enter the PIN, what we do, what the ATM software does, is it will compare whatever customer entered with whatever you initially created when the account was opened. It will compare 4-digit PIN here, the value 1234, and whatever value customer entered. This is what you print. Okay, if this two is fine, then welcome. If it is not, this is the sign. If it is not equal to, what do you say?
Try again.
Okay, compare the pins. This is for comparison, equal comparison. If this is equal to whatever customer entered. This is for comparing not equal to. If this is not equal to what customer entered, we will show them this message, try again. It's as simple as that. Equal sign, not equal. Greater than, less than. That's how you write the code. The ATM software knows what's your balance. The ATM software knows what's your 4-digit PIN. You go to withdraw, you enter the withdraw amount, you input the withdraw amount. So we compare. If balance is greater than what customer entered, give them cash. If balance is less than what customer entered, show them the error. Same goes to this. Same goes to this. Okay. Now what you need to remember is this equal, the relational operator, greater than, less than, equal, not equal. They will result in one of the two options. What are they? What is your answer if I say, is your balance greater than withdraw amount? What is your possible answers?
2.
Yes.
Yeah. No.
What's that?
Yes or no?
Yes or no? So what is the data type that represents yes or no?
Boolean.
Boolean.
Boolean. So basically the relational operators result in Boolean.
Boolean.
So if you see is balance less than withdraw amount, the answer is usually true.
True or
Yes,
false?
balance is less than withdraw amount. Or it is false. No, balance is not less than withdraw amount. So the output of relational operator is what? What is the output?
Boolean. Is true.
Boolean. Okay, so let's look at an example. Int a equals 10, int b equals 20. in sysout, what I'm going to write, just look at this. I'm going to write A equals B. So what's your answer?
False.
False. Is A equal to B?
No.
Will it print 10, 20?
No.
It will print yes or no. That is Boolean.
Mhm.
Sure.
10 is not equal to 20. It is false. What if I do like this? Not equal to?
True.
The output of relational operator is
Boolean. True.
Boolean. Does everyone follow this?
Yes.
What will it print?
False.
False.
This means greater than. Is A greater than B?
No.
No.
Is A less than B?
Yes.
Yes.
True.
Okay, so remember there are four type of relational operators: greater, less than, equal, not equal to. Four type of relational operators. Four ways you can compare two variables, A and B. Okay, the output of these operators are usually Boolean. It will result in something like yes, it is true, it is less than, or no, it's not true, A is not less than. That's how your answer come out when you have relational operators. Okay, true or false. Now one more thing, what you have is, what will it print?
True.
This
Oh,
means
no.
less than B. Is A less than B?
No.
No.
Why
Now
false?
right? Now let's take the balance example. If you have a balance of $10 and you're trying to withdraw $10, you wrote the code like this. Now, technically speaking, if you have $10, will the ATM allow you to withdraw $10 or not?
Yes.
Yes. So your code usually goes like this. If balance is greater than withdraw, with this program, will it allow to withdraw them?
Mm,
Technically, what we want is balance greater than withdraw. But this is not true, right?
Yes.
The
Not.
ATM requirement says balance should be greater or equal to withdraw, isn't it?
Yes.
So when you write a code like this, it will result in
False.
false, and customer won't get their money. So there, what you can do is you can merge. So what this means is balance should be either greater or
Equal.
equal. Okay, balance should be either greater or equal to withdraw amount. This will allow customer to withdraw money. Okay, so what are the operators? Relational operators? Equals. Remember, two equal sign.
Mm.
What is this?
Not equal.
Not equal.
Greater.
Less than.
Yes. Greater than or equal to.
Greater and
Greater
equal.
or equal to.
Not equal to. Less than.
Less.
less than or equal to. Okay, so you can use any combination of this for your usage. Login. When you log in, what happens really?
You log in.
Comparing.
Comparing.
You enter user ID password, right?
Yes, and it will then
Yes.
compare, yeah,
What do we compare that with?
with the saved one.
With the user ID password that you created when you registered, isn't it?
Yes.
Yes.
Okay, so you go to Facebook and you register a new profile. This is the first time when you created your Facebook account. What do they ask you when you are registering on Facebook site?
अहिले 251 मा सम्म चाहिँ एउटा मिटिङ बस्न सक्छ भनेको होला त्यो
Okay, they ask you to enter user ID, first name, last name, address, all this information, isn't it? This is what you enter when you register. Okay, this information stays with them. They save this information somewhere on their machine, on their PC, computer. They store all this information when you register. User ID, password, first name, last name, address, everything. So the next day, when you log in, what do they ask you?
User ID and password.
User ID and password.
They say enter your user ID and enter your password. So what do they compare this user ID and password with?
With the
With the
registered one.
registered one.
With the one you registered with. Okay, they compare this user ID with what you entered when you registered. They compare this with what you entered during password. Isn't that a relational operator usage again?
Yes.
There you go. You're using these relational operator everywhere. While shopping, using the website. Every time you log in on every website, it's being used. You transfer money, it's being used. Every time the relational operators are in play. Okay. All right. So unary operator plus and minus. Okay. They basically use. They basically negate or convert that into positive. Okay. So let's see this. If I give you a number -1 and I ask you to negate, what will be the answer? What is
One.
minus of -1?
1. Positive 1.
+1. What is plus of -1?
-1.
-1.
So you guys understand that basic thing, right? Plus, 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 minus,
Minus.
minus. What is minus, minus?
Plus.
Plus.
Plus. Okay. So these operators are what you can use to convert into minus and pluses. Okay. They usually go like this. I'm converting the number 10. I'm negating. Okay. What will it print?
-10.
-10.
What happens when I do the same now?
It will print 10.
10.
How about
-10.
-10? Minus of minus is plus.
Minus. Plus.
What is plus of minus?
Minus.
Minus. Okay, so you can use this minus and plus operator to convert numbers into other signs, provided you still know that minus minus is plus, plus minus is
Minus.
Minus.
minus. What is minus plus?
Minus.
What is plus plus?
Plus.
Plus. Okay, so remember this usual conversions, they can apply to these numbers, integers, floating numbers and all. Okay. That's what we call unary operator. Okay. Now here we have an increment operator. Okay, so let's see what is the increment and decrement. A plus plus. What this means is increment
20.
By 1.
by 1. What will it print?
11.
11.
11 or 20?
The current value is 10. Increment by 1. Plus plus means increment by 1. So when you increment 10 by 1, what happens?
11.
Now
9.
this is increment operator. This is decrement. This is increment. Okay, increment operator and decrement operator. Now here is where it gets tricky. Increment and decrement can come in two flavors, post and pre. This is what we call post.
After.
After. And pre is
Before.
before the variable name. How do we operate this? Let's say.
Print.
Okay, what will it print?
11. 20.
Okay. Post means the increment should be done on the next line. Post means increment should be done on the next line. So what will it print here?
11.
Post meaning the increment is done on the next line. So in this line, what was the value? 10. Here, the value was 10. And on the next line, it got incremented to
11.
11. Pre means increment before this line. So before this line, what will be the value? 12.
12.
Pre value will be
13.
This is post. So do I increment here on 11 or 13?
13.
Here is 14.
Okay, value becomes from 13 to 14. So what will it print? At this line, what was the value of A?
10.
10. It became 11, became 12. So what will it print here?
12.
Became 13. What will it print here?
13.
And here?
13.
10, 12, 13, 13. Post increment means on the current line, you don't do anything. This will be incremented on the next line. Post this line. This means pre, before this line, you have to increment that. Pre, post. Okay. Before this line itself, you have to increment, and then you'll see the new value. Post, pre. Same applies to decrement. Okay, same applies to decrement. Guess the output. Just do what I did. Write the value below that line, after the line, before the line.
Nine. That's 10. 9.
10, 9.
Again 10. No. Yeah, no. Then 10. After. Before.
Anyone has the answer?
10, 10, 11, 11, 11.
10, 10, 11, 11, 11. Any other answers?
No.
So where will this increment? On which line number?
6.
So here A will become
11.
11.
so on line number 5. What was the value?
10.
10.
10.
Still 10. So yes, first number is 10. Will it decrement before this line or after?
Before.
Before.
What will it print here?
10.
10. Will this increment before or after?
Before.
Before.
What will it print?
11.
11.
How about this?
After.
After.
After. A becomes
10.
10.
so in this line, what will it print?
11.
11. How about this one? It will increment before or after?
Before.
So yes, 10, 10, 11, 11, 11. Do you guys follow how the pre and post increment decrement works?
Yes.
Okay, you increment or decrement before that line or after that line based on where you apply it, pre or post. Pre or post. Okay. All right, so there are logical ANDs and logical OR. Okay, so let's see if you guys know these logical AND and OR. What is true and true?
false,
Okay, so this is
false,
this one
false,
false,
is
false,
true,
false. Okay, for logical and, both have to be satisfied. If both are true, only then it is true. This is false, this is false, this is false. Look at the user ID password example. You compare user ID and password, don't you? If both are true, only then you log in, isn't it? Will the Facebook allow you to log in if your user ID is correct and password is wrong?
no,
How about your user ID is wrong and password is correct?
no,
What if both your user ID and password are wrong? Do they allow you to log in? No. The logical and is what you use in login pages. That is nothing but the double ampersand. Okay, double ampersand is used for the logical and. The same thing if you do it for or.
This conference will now be recorded.
All right, so true or true, it's a either or condition.
true,
false,
True.
true,
True. False.
That's it. All right, so this is logical or. Okay, so any example for this? For the logical or? On a website? Anywhere you get multiple options to enter?
Like we can sign up using an email or the phone number.
Yes. Okay, either email or phone number. You can enter either one of them and it will let you. That's the logical or. You forgot your password. What do they ask you?
Security question.
Either security question or give me your personal phone number that you registered with and I'll text you a 6-digit pin, 8-digit pin. Don't they say that? They give you multiple options, right? Either do this or that. Any one of the choice you pick, you can still work with that. Forgot password. Log in with email ID or phone number. Either or. Okay. Now let's see how we use that in our code. I'm just giving an example. Now, how can you use the and or maybe or? Okay, use either logical or logical and to solve this problem. to solve the withdraw logic. What is the rule for withdraw?
Greater than. Balance is greater than.
Balance equal to? What is the condition for withdrawing amount?
Balance should be greater or equals to withdraw.
Balance should be either greater than withdraw or it should be equal to withdraw. Do we say or do we say and?
Or.
Or.
You say or. So this is how your code would look like. Either balance is greater than withdraw or balance is equal to withdraw. What is the output of this condition?
True.
True.
Boolean. Okay. Technically, what you get from relational operator is
Boolean.
Boolean. Greater than, equal to, less than, not equal to. What you get from this is a Boolean. Okay. So how does this translate? How does this code translate? These are the rules. We know how logical and or operates. Okay. So when you have a code like this will translate to like this. First, give me the answer of this part.
True.
True. That is step number 1. Give me the answer of second part.
False.
So now, what is true or false?
True.
True.
It's true. So when this true or false turns out to be true, okay, true or false will give true. So finally, when this condition overall becomes true, you let them
Give the cache.
you cache. Okay, so that's how it resolves. You basically have a relational operator, bunch of relational operators that try to run on top of and or condition. Okay, so you usually mix up greater than equal symbol with or and this one. So for this example, how do you write the condition? Register and login.
If user ID and register user ID and register password is equal, yeah, login user ID equal.
Do I use and
Yes.
or logical or?
And.
Login password.
Login password.
So technically, and is never used standalone. It is used in a combination with relational operators. Okay, so you need to use relational operators along with logical operators. Okay, you mix both of them. The user ID is equal to login user ID the registered password is equal to login password. If both are true, and true, then we will welcome you. Else we won't. Okay, so usually AND operator or operator goes in combination with relational operator. Okay, because we know this will output what? Relational operator gives what output?
Boolean.
Boolean.
True. So this is
Relational
true.
operator gives Boolean, and logical operator works on
True and false.
Relational
Boolean. Okay? So both of them have Boolean. Logical and logical OR requires Boolean for comparison, and relational output gives Boolean. Relational operator gives Boolean, and logical operator needs Boolean. Remember that. What's wrong with this?
We need to have comparison before using and.
What does logical operator require?
Relational operator.
It requires Boolean and Boolean, isn't it? Okay, few things you need to understand. The relational operator only applies to numbers. Okay, relational operator compares number. And what is the data type of numbers?
Integers,
It can be integer, long,
float.
short.
And so on. Okay, it can only compare numbers. Now, what is the output of relational operators? When you compare two numbers, int and int, what is that you get? If I say is 10 greater than 20, what do you say?
Boolean.
Boolean.
Boolean. That's how your answer is. Is 10 greater than 20? You say no. Is 20 greater than 10? You say yes. Isn't it?
Yes.
So output for relational operator is
Boolean.
Boolean. Okay. Input is numbers, integer, byte, float. Output is Boolean. That's what relational operator requires. The logical operators and or, what do they require? What is the input?
Boolean.
And what is the output you get?
Boolean.
Okay, input is Boolean, output is Boolean. Input are numbers, output are Boolean. So we mix and match them both. You cannot say this. How about for the logical AND on the left hand side, right hand side? Can I use balance and A?
No.